Alkenes and alkynes react with hydrogen halide to form an addition product called haloalkane or alkyl halides. Addition of hydrogen halide in unsaturated compound proceeds through following possible ways. The number 1 is hydrogen halide in dry gaseous form can be directly passed into an alkene and it is added across the double bond to form a single bond. The second one is moderately polar solvents can be used which will dissolve both polar hydrogen halides and non-polar alkenes. In case of alkynes, the catalyst is added because alkynes are less reactive than alkenes. Metallic halide help to speed up the reaction. If more than one molecule of hydrogen halide is present, then alkynes will be converted into haloalkene and haloalkene can further react with hydrogen halide to form gem dihaloalkane. Here we have two reactants as you can see in the reaction equation. Hydrogen halide has unsymmetrical charge distribution due to large electronegativity difference between hydrogen and halides. The second reactant is unsaturated compound which may or may not be symmetrical. Nature of compound is very important as it determines how the reaction will proceed. Addition in symmetrical compound is quite easy as they have same number of hydrogen atoms attached to both doubly or triply bonding carbon atoms. As you can see in the figure that both unsaturated carbons have one cyclopropane and one hydrogen atom. Due to this symmetry in structure, the incoming hydrogen can bond to any of the unsaturated carbon. Product will be same no matters at which carbon atom the electrophilic hydrogen attacks. But while dealing with unsymmetrical compounds, addition reaction become a little bit complex. Unsymmetrical compounds have no symmetry in their structures. Doubly or triply bonding carbon atoms have different number of hydrogen attached. Incoming electrophile has to decide the feasible location for attack. In such cases, Markovnikovs rule operates. It states that in the addition of unsymmetrical reagent in unsymmetrical alkene, the negative part of adding reagent goes to that carbon constituting the double bond which has these number of hydrogen atoms. In simple words, hydrogen halide is unsymmetrical reagent having partially positively charged hydrogen and partially negatively charged halide. When it is added to an unsaturated compound having different number of hydrogen attached to doubly or triply bonding carbon atoms, then the negative part which is halide in this case will go to carbon having least number of hydrogen atoms. So we can say that negative part will go to carbon which is less electropositive. Markonikov's rule can also be defined as in the addition of hydrogen halide to the carbon-carbon double bond of alkene, the hydrogen atom attaches itself to the carbon atom of double bond that already holds greater number of hydrogen atoms. According to this statement, the positive part which is hydrogen in this case will go to carbon having greater number of hydrogens. So positive part will go to carbon which is more electropositive. Addition in alkenes. Markonikov's rule predict the actual product formation. Suppose we have one propionine. First carbon has two hydrogens and second carbon has only one hydrogen. When hydrogen bromide will react with one propionine, there is possibility that two products can be formed according to the given equation. But practically only one product formation take place. In this confusing case, we need guidelines and rules. When we apply Markonikov's rule to this equation, it becomes obvious that hydrogen will go to the first carbon which already has two hydrogens and bromide will go to second carbon which has only one hydrogen. This will result in the formation of true propyl bromide. Addition in alkynes is a two-step reaction. Suppose we have hydrogen chloride and alkyne in reaction mixture and mercuric bromide is a catalyst. Following Markonikov's rule, hydrogen will go to carbon already having one hydrogen, and chloride will go to carbon having no hydrogen. This will result in the formation of haloalkene. Haloalkene will further react with available hydrogen chloride to form gem dihaloalkane. This step is also in accordance with Markonikov's rule, as hydrogen will go to carbon which has two hydrogen and is more electropositive, and chloride will go to carbon which is more electronegative and holds one chlorine atom.